Hello and welcome to my YouTube channel. Today we are going to learn how to use interrupts to perform any event. In this case, what we are going to do is we are going to attach an interrupt to the switch and blink or toggle an LED on the Nucleo F446RE board. So let's start the video. First of all, what is the need of an interrupt? When we can make simple programs where suppose one LED is blinking, here the red LED is blinking at a particular rate, and suppose we have a system where we have a switch which will control the green LED. Now, if you want to design a program which will respond to the switch at the very instance when the switch is pressed, the green LED should toggle. In that case, we may write a program as shown in the right. For example, in the while loop, while 1, that means it will go for infinite repetitions. The while loop we have written red LED high, we call for a delay of 1 second. So the LED will remain high for 1 second, and then we will make the red LED low and delay 1 second. We are expecting that this loop will keep the red LED blinking at a rate of 1 second. Now we write a program for the switch where if switch is equal to low, that means the voltage at the switch terminal is low, in that case green LED should go low, or else if the switch is high, the green LED should be high. So we are expecting that if we press the switch, the green LED should go low. You can try this code on any microcontroller board, but you will find that you will not be able to toggle the LED or the green LED using the switch. Why so? Because here if you keep an eye on the section where we have red LED high, delay 1 second, and then red LED low, delay 1 second. So most of our time, or the microprocessors or microcontrollers time, is spent in this function, that is the delay function, which may be of seconds. For example, in our case 2 seconds precisely. So for 2 seconds, the microprocessor or the microcontroller will be always busy in the delay function. And to execute this section of program for the switch will take maybe some milliseconds. So out of a window for few seconds, we are getting a small window of millisecond to detect the event on switch. So even if you try, there is a very small probability that the microcontroller will respond to the switch because we are getting a very small time period to read the status of switch. Therefore, in such cases, we will not prefer with this kind of programming. We call this kind of programming polling. So to detect the switch event, we should implement interrupt so that the microprocessor or microcontroller can detect the events on any particular pin using the interrupts. So what are the benefits of interrupts and where should we use them? First of all, interrupts are used to handle events, or we can say event handling. This allows the microcontroller or microprocessor to respond immediately to any external event. For example, in our case, the external event was pressing of switch. So it will immediately respond to any external event such as sensor inputs, button presses, or communication signals. So in case you need any program to respond to an event such as sensor input button presses or communication signals, you should always implement interrupts in your program. Second, when we need real-time response. So, whenever we write a program to detect multiple tasks and handle the task in a very time sensitive manner, then in that case we should always use the interrupts. These are generally used in real-time operating systems also. Thirdly, when we will require any task switching, for example, if you are designing a program with multiple tasks or multiple threads, then in that case interrupts may facilitate you in task switching. Again, this is an example from real-time operating systems. Now, fourth option is whenever you are conducting any communication between the peripherals. In that case, interrupts can handle communication events, timer overflow, or data reception, and managing the peripherals efficiently. Fifth, whenever you want power management or to save power for a particular time period. In that case, interrupts can help you to manage the power. For example, you can make the system to go for sleep and you can wake up the system using interrupts. And therefore, you can save lots of power if your system is designed for power management or if your system is running on batteries. In that case, you can save a lot of power by implementing interrupts. Last but not the least, to handle errors. Interrupts can provide you systems or mechanisms to quickly detect an error and handle that error in a very efficient manner. So remember these 6 points. Whenever you require any kind of support from interrupt, you can use the interrupts for this kind of events. Now, coming to the STM32F446RE microcontroller board and how to check where the pins are and what the pins can do for you. For that, you can refer to the user manual. I have already discussed this part in the previous video also. So when you come down, you can see the connections which are provided to your STM32F446RE microcontroller board. For that, you can check switch. Okay, and okay, so let me check LED. So you can see here the features. It shows the board supports user LED 2 and power LED, and apart from that it also supports onboard switches. So we can come down and see where the switches are connected. So let me just show you bottom layout, LEDs and push buttons. So under section 6.4 you can see LD2 is our user LED, that is green LED, which is connected at pin number D13, or we can say STM32 IO PA5. Make note of this pin number. PA5 port A 5th pin is connected to the user LED. Apart from that, you can make note of push button, that is B1 user button, which is connected at PC13 according to Arduino, but in the microcontroller board we should check port C13. So these two buttons and switches address has to be noted. PA5 for the LED and PC13 for the switch. And secondly, we can check the schematic because that will help us to write a better program. So if you go down, you can see here the LED is connected, user LED green LED is connected to D13, right? And D13 should be programmed to make the LED on off. Secondly, about the switch, you can see here the switch, user switch B1 is connected in this manner. So VDD 4.7 kilo ohm connected directly to PC13. So that means when the switch is off or unpressed, PC13 will be receiving 5 volt, and when we press the switch, you can see it will be shorted and it will be grounded. So PC13 will be grounded when the switch is pressed, and PC13 will be high if the switch is unpressed. So we have to write a program according to the switch connection. So now, after knowing the schematic and the addresses, we can write the program on STM32 CubeIDE. So let me launch the program, and then we can start creating the project. So from here, you can click File, New, STM32 project. Click on that. It will take some time to check if the program is updated or not, and then it will give us all the options for the microcontrollers which are available with us. So I will go for the board selector. Type here F446RE, and you can see Nucleo F446RE microcontroller board is available. You can select that and click Next. Give a name to the project. So here the project is created under D STM32 underscore workspace. You can create any other folder according to your choice and save the project there. So let me give a name LED switch and interrupt, and click Finish. So it will give you a prompt: initialize all peripherals with their default mode. I don't want, so I will click No, and will open the CubeMX perspective. This may take few seconds, so wait. And now we can see the CubeMX perspective. Here we have the microcontroller which we are going to program, and first of all I will go to the pinouts and clear pinouts. So clear the pinouts which are there and click Yes. Now we can start writing the program. So first of all, if you recall, the LED is connected at PA5. So click on the PA5, make it a simple output, GPIO output, and rename it. For that, right click on the pin, enter user label, and give it a name LED. Now PC13 is here. If you find it difficult to find the PC13 or any other pin, just on the right bottom here you can type the name PC13 and it will show you where the pin is located. So click on the pin and go down. Here you can see GPIO EXTI13, which means GPIO external interrupt 13. Click on that. So we have enabled the interrupt functionality on the pin, and let us rename it. For that, right click, enter user label, and let me give it a name button. Okay, enter. After this, we have to go to the system view. From here, you can check NVIC, one option to enable the interrupt. On the bottom, you can see EXTI line 15 to 10 or 10 to 15 interrupts. You can check this line, or another option is you can click here, minimize this window. Another option is you go to the window here, the left pane, you can see NVIC. Click on that. Okay, and you can enable the interrupt from here also. NVIC, go down, EXTI 10 to 15 enabled. So that means we have enabled the interrupt on the pins between 10 to 15. And then you can click save or save all. Once you click save all, it will generate the C code, and apart from that, you will enter in the C perspective. Before you were in the Cube MX perspective, now in the C perspective. Adjust the window, go down. Here you can see all the codes related to your program has been initialized. Only thing is we need to write a code to handle the interrupt. In the left you can see driver files, core files. So in that you can check source. In that you can see STM32F446RE. Click on that. This file is related to all the interrupts. So in the outline you can see all the functions available with the STM32F446RE file. So here are all the functions which are available in the C file. Apart from that, you can go to CMSIS, device, STM32 and source and templates. Sorry, you don't have to check this window, wait. So you have the STM. Here you can see EXTI 10 to 15 IRQ handle, and this shows EXTI IRQ handle void. In that you can see Hall GPIO EXTI IRQ handler button pin. So first we have to check where this handler is. Open the declaration, and here you can see the EXTI IRQ. So this is all about the IRQ. Now let us take the help of this IRQ file and write a function to handle the interrupt. For that, you can go to the STM32F4XX Hall. Under that, you can see GPIO. In the GPIO, you can see GPIO EXTI IRQ handler and GPIO EXTI callback function. So you can read this callback function helps you to detect any interrupt on the EXTI line. So GPIO pins specifies pins connected to EXTI line, and this function is declared as weak. So we can use this function in our main program. So copy this function, void all underscore GPIO EXTI callback. Copy this. This callback will be generated whenever the interrupt is generated. So we can put it here somewhere here between the user code begin and user code end. So paste it here and two curly braces, and here we can just write hall underscore control space GPIO underscore toggle pin function. So whenever the external interrupt pin is pressed, we can toggle the pin which is connected to the LED. So here, to know what to put in the GPIO X or GPIO pin, you can go to the functionalities here where you have enabled the GPIO. So GPIO init to initialize the GPIO. You can see the port name is GPIO port, LED GPIO port, and the pin name is LED underscore pin. So these two parameters has to be passed here. So X means LED control space GPIO port, and then for the pin we can type LED underscore LED pin. This is all required to handle the interrupt. You can see here, let me close all the other initializations so that the window looks much cleaner. Here you can see in the main void, we have initialized the hall. Clock has been configured. GPIO has been initialized. And while this function is empty. So we are not touching this function. Instead, whenever the switch will be pressed, it will directly jump to the GPIO EXTI callback. And in the callback, we are toggling the user LED, which is the green LED. Let us compile the program. For that, you can click on the hammer, and we have debugged the program, and we can see 0 error, 0 warnings. And now we can use the debug window to run the code line by line. Click OK. And then after that, this window will come, edit configuration, just click OK. If your board is connected to the microcontroller, board is connected to your PC, then debug window will appear. And now from here you can run the code line by line by using this function step into, or function by clicking step over. For example, like this. Okay. Here you are stepping into each and every line or code line by line, and here you can click come out of the function, and here you can go function to function while debugging the program. So now once the program is working, you can see we are always in the while window. So because the button has not been, or the switch has not been pressed yet. So let me start the camera to show you the status of my board. I hope now you can see my camera and the microcontroller board. And let me run the code by clicking resume F8. So I have clicked the resume button, and let me press the user button, and you can see the LED toggles each and every time when I press the user button. Here we are not doing the polling operation, because you can see inside the while function nothing is written. So whenever the switch is pressed, the interrupt is generated, and the interrupt takes the program directly to this window where you are toggling the LED. Remember, you should always keep the program inside the callback function as small as possible, because you don't want to give too much time to any interrupt related functions. So now with that, I would like to end the presentation. So thank you. If you have not subscribed my channel, then please subscribe my channel and press the bell icon so that you can receive the notifications when I upload a new video. If you have any doubts or suggestions for this video, please post your comments and suggestions in the comment section. Thank you and have a nice day.